Welcome to session 1 of calculus, the study of change, meaning differential, and the area, meaning integration. But session 1 of calculus will focus mainly on the limits and continuity. Limits and continuity. The limit is the fundamental concept of calculus. It is important to comprehend fully the definition and how the limits function with respect to calculus, with respect to sum to infinity. Before we go to calculus directly, I'm going to refer back to sum to infinity of the geometric series. An infinite number of terms doesn't necessarily mean they are added up. The infinite geometric series converges if and only if the ratio R is lesser than 1 or greater than -1, meaning that the ratio R is a fraction. It is a positive or a negative fraction. Therefore, the sum to infinity is equals to A over 1 minus R, A being the first term of the sequence or series, and R be the fractional ratio. Now, the ratio is a fraction. The series converges. It means there are infinite numbers, infinite fractions within 1 and -1. Let's go to case study and see what this is all about. Let's determine the sum of infinite geometric series. As soon as it says infinite, it means it is continuous. Therefore, 1 over 3 plus 1 over 9 plus 1 over 27 plus all the values to the general term, which is 1 over 3 to the power n. It goes on infinitely, this series. Therefore, A is 1 over 3 and the ratio is 1 over 3. Therefore, the sum to infinity for A, it will be 1 over 3, and for R, it will be 1 over 3. Therefore, we have 1 over 3 over 1 minus 1 over 3. Therefore, the sum to infinity of this series is half. Half means 0,5. Therefore, this series converges to 5. It doesn't mean it is equal to 5. It converges. Remember, an infinite number of terms doesn't necessarily mean they are added up. Now, if the ratio is a fraction, the series converges. Ratio will be between 1 and -1. The sum to infinity, which is half, equals to 0,5. It means the series converges to half. It means whatever it is that we do, we will go towards half. as the sum of number of terms tends to half, number of terms tends to infinity. Algebraically, it means sum of number of terms tends to half, therefore number of terms tends to infinity. This means the limit of n as n tends to infinity, the sum of number of terms is half. So the sum to infinity means the limit of n tends to infinity as n is equals to half. Or using sigma notation, number of terms infinity as n equals to 1 being the first term, for the general term 1 over 3 all raised to the power n is the same as this. You can use this method, you can use that method, you can use this method, you'll get the same thing. My aim is to emphasize the importance of the limit. This series converges to half. Let's see, what do we talk about when we talk about conversion, coming together towards a certain point. They are not diverging as moving away from one another. They come together, they converge to 0,5. Let's analyze the general equation of geometric series if the ratio is a fraction, meaning r lesser than 1, r greater than -1. This is how it works. We have a all into 1 minus r raised to the power n all over r minus 1. Our a in this case is 1 over 3 minus our r, which is 1 over 3 raised to the power n all over this. We get half all into 1 minus 1 over 3 raised to the power n. This is represented by this. Now, the sum of one term will be equals to 0,333, which is a third. Then the sum of two terms will be 0,444. Now, as we add these terms, they tend to 0,5. Then the sum of 4 will be 0,4938. To the nearest term, it is 5, 0,5. Sum of 5 will give you 0,498. To the nearest term is 5. Therefore, the limit as the number of 10 tends to infinity, the sum of number of 10 is 0,5. The sum of 6 terms is 4,99. It tends to 5. 7 is 0,2714. 8 is 0,4238. 9, 0,74. Nearest term is 0,5. Nearest term is 0,5. Therefore, these numbers, the limit as n converges to infinity, as n is equals to 0,5. The limit doesn't necessarily mean we reach 0,5. We get approximately to 5, just near 5, 0,5 rather. Now, let's look at case exercise 1. Let's determine the limits. Let's determine the limits. n tends to infinity of this expression. The second one will be this one. Now let's start with case 1. Case exercise 1a. The sum of one term will be 0,5. Of 3 terms will be 0,86. It means 0,9. It means we go to 1. Sum of 5 will be 0.97. To the nearest is 1. Therefore, the limit as number of terms tends to infinity, the sum of number of terms is 1. The same as b. B, there is b. There is b. Therefore, we do the same. Now what happens here? The sum of one term will be 1. Of 3 terms, 1,44. It means we are targeting 0,5. Then it gives us 0,148, the sum of 4. Then it means it's 0,15. Therefore, the limit, as the number of terms tend to infinity, the sum of number of terms is 1,5. Remember, this doesn't mean infinite terms are added. It's impossible. There are infinitely many, especially when they are not restricted. Now, case exercise 2, determine the sum of infinite GS 3 plus 1.5 plus 3 over 4, blah, blah, blah. It's for you to do it. If you cannot, you can click and tell me, then I'll be able to help out. Now let's come to calculus directly. A preview to calculus. Let us start with the slope of a straight line. The slope of a straight line is the ratio of the rise in y to the run in x. That is, change in y over change in x. When we opened up, we introduced calculus as the study of change. This is the rate of change. Differential means the rate of change. It means the gradient. Now, in a straight line, the slope is constant regardless of which 2 points are determined. Let's take point AB, and here is your graph. A is here, B is here. We have 5 minus 3 over 3 minus 2, which is 2. Then we take CE. CE. We have 1 minus minus 3. There it is. And we have 1 minus minus 1, which is 1. Therefore, the slope will be 2. It's the same. It's constant. Then we take AD, A and D. We have 5 plus 1 over 3 minus 0, which is 6 over 3. It gives you 2. So the slope is constant. It's the slope of a straight line. Now, in session 2, we are going to talk about the review of calculus, the preview rather of calculus, and explain in depth what does this mean. In other words, you are trying now to distinguish between the slope of a secant and the slope of a tangent. Like the video, subscribe, and the more you subscribe, the more I'll be able to bring more content. I'm out of here. Keep well. See you in session 2.